Okay. So we're actually going to look at a little bit of calculus today and talk about that. Like I said, we have like 20 minutes, so not a lot of time, but we'll get in what we can here. All right, so a piece of paper out, and we'll just take a look at that. All right. Okay, I know the last thing you want to do after a quiz is like learn some more stuff, but the good news is this is the last little bit of limit stuff that we're going to be having to worry about. Okay, for the test that will be coming up later. So. We're going to talk about the slope of a function, which might seem like an odd place to start since you've been talking about slope, right, since at least algebra 1, at least related to a line, right? So, but there's actually kind of a broader idea of the slope of a function that we'll kind of introduce here. So let's first talk about, or let's consider, okay, y equals 2x plus 1. Okay, so a simple line, right? If I can sketch a little quick graph of it here, it's already in slope-intercept form for us. So I'll just like draw some axes over here. Okay, bless you. It's got a y-intercept of 1, so like put that right there. Okay. All right, and then slope of 2, so that means we're going to go up 1, 2, right 1, up 1, 2, right 1, something like that. Ooh, that's not very good. There you go, it's a bit closer. And so we can draw our line, given that relationship there. Okay, something like that. Not perfect, but you get the idea. Okay, and so what's the slope of this line again? Anybody? Yeah, it's 2, right? The slope is 2. Okay, or if you want, you could say 2 over 1, right? Since, you know, we can also write it as a fraction. Okay, so the idea then, right, is that the rate of change of this line is 2, and really it's 2 everywhere, right? Because no matter where you are on the line, any 2 points you pick on that line, you're going to have to find, you can find the slope between those 2 points, and those 2 points will always, you know, result in a slope of 2 on that line, right? So it's like pretty straightforward stuff, right? We knew this. This is like algebra 1, maybe even prior to algebra 1, I don't know, okay? But that's easy stuff, right? But now let's consider y equal to negative x squared plus 4. Alright, let's consider y equal to negative x squared plus 4. And I'll sketch a graph of this. Okay, again, this one shouldn't be too crazy either because it's just a transformation of y equals x squared. We're all familiar with that. Looks like a parabola, right? And so let's see here. 1, 2, 3, 4. So the vertex is shifted up 4. And because it's negative x squared, it's going to be flipped over the, well, sorry, the original x squared is flipped over the x-axis, so it's kind of like a frowny face parabola, right? Okay, and specifically, I know it's got zeros at 2, 0, and negative 2, 0 as well. So I can just kind of sketch this thing. Okay. And so, let me ask the same question. What's the slope? What's the slope of this? What's the slope of this? All right, so Cole, what do you say? Negative 1? Okay, how'd you get that? Okay, so you're kind of going back to the idea that, hey, this is slope-intercept form for the line, and so the slope we identify as 2, it's the number in front of the x, and so we look down here, this is kind of in what looks like a kind of slope-intercept form-y kind of deal, right? And there's a number in front of the x, and it's a negative 1, so maybe the slope is always negative 1, okay? Not a bad thinking there. Not bad. Any other ideas about what the slope is here for this thing? Well, so I'm kind of, putting the cart before the horse here, because I'm saying what is the slope. But maybe the case here is that there's not just a slope, maybe there are many slopes, right? And so this is a bit of a different kind of question here, because you look at this, you're like, well, it doesn't really look like a line, so how can we even determine the slope here? But I'll tell you right now that you all already have like an intuitive sense about what the slope of this thing would be. For example here, okay, if I were to talk about this right here, the slope at this kind of point on the graph, would you call that slope a positive slope, a negative slope, or a zero slope right here? What would you say? Positive. Why would you say positive? It's going up from left to right. Yeah, and you would be right. That is going to be a positive slope there at that point. Okay? So, we could say right here, we think the slope is going to be positive. And you'd be right. Okay? What about at the x value of 2? What would we expect the slope to be there? Negative, right? Because we're going down as we go from left to right. So yes, the slope here, we want it to be negative, and it would be negative. Okay, and there's even a point on this graph where I think many of you would be able to identify the slope exactly by number. What is the slope at this point right here going to be? It's going to be 0. Why? Why at that instant? Yeah, Devin? At that instant, we kind of have like a horizontal kind of slope, right? You can imagine that our slopes are going to be all positive here because we're always increasing, so our slopes are going to be positive, 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 and then it kind of peaks at 0 slope, right? And then it's going to be negative, or sorry, not peaks, I guess they're decreasing down to 0, and then they start going negative, like that, okay? And so the slope, okay, the slope is changing, okay, depending on your location on the graph. Okay. So the question still remains then, how do we find the slope, right? I mean, we feel pretty good that, okay, we can find that we know that the slope's, and we kind of think that the slope's positive here, and that's a good idea. And we think the slope's negative here, and so that's a good idea, okay? But can we be more precise, right? We know that here, for example, it's exactly 0. Can we be more precise here in finding these individual actual slope numbers at those points? And the answer is yes, okay, we can. So how do we find the slope of a function at a single point? Right? That is the question we want to be able to answer. Because right now, we know how to find a slope, but we only know how to find a slope if we've got 2 points, right? We have the slope formula, and the slope formula is only good for lines, really, because you need 2 points. Here, if we try to use 2 points, well, if I pick, like, for example, if I pick my point here, and I pick the point here, and I try to find the slope between those points, I could do that, but I don't want the slope between these 2 points. I want the slope at this point, and I want the slope at this point, because they're 2 different slopes, right? We said here the slope was positive, here the slope is 0. So if I try and use slope formula between those 2 points, I'm not going to get their slopes. I'll get like some other kind of slope, right? I'm not going to get that. I'll get a positive slope, but it won't be exactly this slope, and it won't be exactly this slope. So how do we find the slope at a single point? And that's where we introduce the idea of the derivative. Okay, the derivative. Okay, the derivative is a limit, okay, used to find the slope of a curve. Okay, should you move on to calculus, okay, in your future, the derivative is going to be fundamental to like half of calculus. Okay? And it is mathematically defined as f prime of x So when you refer to the derivative of a function, you refer to f with a little apostrophe and then the x there, f prime. Okay, prime, that's like, we read that as f prime of x. And that's going to be equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay. That may look familiar to you, right? It's the difference quotient. All right, it's the difference quotient with a limit thrown in. The limit is h approaches 0. Okay, now, your calculus teachers will go into a little bit more depth about where this comes from, okay, and why, why it is the way it is, right? For right now, we're just going to kind of do it. Suffice to say, it is an application of the slope formula, okay? It is an application of the slope formula, but we're not going to get into the specifics of it right now. This is how you find the derivative. You guys will talk about that with your calculus class. And it's not because I don't want to, it's because we just don't have the time, okay? So, let's do 2 examples here. And when I say this is fundamental to half of calculus, yes, you'll be using the derivative for like half your calculus. You won't always be finding the derivative using this limit. You'll find shortcuts and, kind of like rules and stuff like that that'll help you take derivatives more efficiently, quicker, than this. But this is where you all will start in calculus, or eventually get to in calculus to start the calculus. So let's find the derivative of f of x equals 2x plus 1. So we're going to go back to our original line equation here, and we're going to find the derivative of that. Okay, so I want to take the limit as h approaches 0 of f of x plus h minus f of x all over h. So we have to plug in our stuff. So I know that f of x is 2x plus 1. So that kind of takes care of that piece. I know what f of x is. It's going to be the 2x plus 1. I need to figure out what f of x plus h is. So let me just go ahead and do that here underneath. So if f of x is 2x plus 1, then f of x plus h will be 2 parentheses x plus h, right? The x is replaced by x plus h, so this x will be replaced by x plus h as well. So it'll be 2 x plus h plus 1, right? These two things. Using our function rule there, we'll just replace the x with x plus h. And so now I can evaluate this limit. F of x plus h I know is going to be 2x plus h plus 1 minus, so there's the f of x plus h, minus f of x, so that was 2x plus 1. I'll put that in parentheses. All over h. All right, so questions about that substitution? Are there any questions on the substitution? Okay. Again, you need to figure out what f of x plus h is. Sometimes you can do that as a little side work. Sometimes you can just do it straight up if you feel comfortable. Okay. Then plug in f of x to our function, and now we'll simplify, right? So you could plug in 0 for h right now if you wanted to, right off the bat, but you'll notice you're going to get 0 over 0. But things will cancel once we distribute here and combine like terms. Okay. So some things cancel, right? For example, 2x minus 2x, they cancel. 1 minus 1, they cancel. And so we're left with the limit as h approaches 0 of just 2h over h. Which then what can we do here? Cancel the h's. And so we're left with just limit as h approaches 0 of 2. And what is the limit as h approaches 0 of 2? What does that equal? 2. Yeah, the answer is 2. Which makes sense because what is the slope of this line no matter where we are? 2, right? So we shouldn't be surprised by that. That should be like, duh, why do we have to do all that work? Well, just to practice using the difference quotient. Okay, practice using that difference quotient. All right. Questions on any of that? I want to squeeze in one more here. because I want to do the other one that we did, the negative x squared plus 4. Okay, so let's also find the derivative. Okay, of f of x equals negative x squared plus 4. Okay, this one I'm going to just do a wee bit faster just so we can get through it. So the limit as h approaches 0. I'm going to go ahead and do my, well, now I'll go ahead and write this down again. Alright, f of x plus h minus f of x all over h. And now I'll do the substitution. So h approaches 0, it'll be, let's see here. So f of x plus h is going to be negative x plus h squared plus 4. Right, it was negative x squared plus 4, so we replace the x with the x plus h. Minus then f of x, so it's minus the quantity, negative x squared plus 4, all over h. Okay. And now to simplify this, I have to FOIL out that x plus h quantity squared. Alright, unfortunately, which is going to be then negative x squared plus 2xh plus h squared plus 4. Okay, and then minus the negative x squared is plus x squared, and then minus 4 when I distribute the minus sign there too, all over h. Okay. I also need to distribute this minus sign. Once I've FOILed out the x plus h, I have to distribute that minus sign, so I've got the limit as h approaches 0 of negative x squared minus 2xh minus h squared. I'm going to run out of space. Okay, so again, all I did was there just distribute that minus sign. Negative x squared minus 2xh minus h squared. Okay. Got a little bug. Alright, cancel things out. Negative x squared and x squared. Positive 4 and negative 4. We've got negative 2xh minus h squared all over h. How can we simplify this from this point? Factor in h out of the numerator, right? We have h times negative 2x minus h all over h. The h's cancel. I get negative 2x minus h. Oh, sorry, the limit is h approaches 0 of negative 2x minus h. And now I can substitute in the 0 for the h, right? Since the h is canceled, I can now finally plug in that 0. I won't be dividing by 0 anymore when I plug in 0 for h. I can plug in the 0. I'm left with negative 2x. How the heck is that supposed to be a slope? Well, remember, what did we say? The slope is changing. The slope is changing. So for different x values, you get different slopes, right? If our x value is 0, negative 2 times 0 is 0. Okay? If our x value is positive 2, then it'll be a negative 4 slope, and if our x value is negative 2, it'll be a positive 4 slope. So, anyway.